Hi everyone. In this video, we are going to learn how to express data in point-slope equation, or to get an equation for your line, or we're going to continue the context and you're going to be able to write an equation for your profit graph. So for this context, again, we're going to use a Miss Mancini candle business. All the information is the same. We have the same graph, but now we're going to write an equation. Okay, so I'm going to introduce you to the form called point-slope form. In point-slope form, math people are not the most creative. The name of it is exactly what you need to write it. So to write an equation in point-slope form, you need two things. First, you need a point. Any point on the graph will do. And second thing you need is a slope, hence the name point-slope formula. Okay, so for example, on our Miss Mancini's candle graph, we can pick any point. So I could pick the y-intercept. I could pick the x-intercept. I could pick any random point on the graph, doesn't matter, or any point from the table. So maybe I'll pick this 8, -40, which is right here. Okay, I'm just choosing this for fun, but you can pick any point you want. So to express that as a point, it's x comma y is 8, -40. And the second thing you need to write an equation in point-slope form is the slope, which we've calculated in the previous videos. Remember, slope is rise over run. Okay, so we rose 50, we ran 5. So our slope was 50 over 5, which was 10. Okay, so in our example, our slope is 10. So once you have the point and the slope, that's all you need. You're just going to write it in the following format. So I'm going to write the general form here and show you how to plug it in here. So point slope formula looks like this. You take y is the variable, and you subtract whatever your y-coordinate is. And that's equal to your slope. It's important to note that math people always use m to express slope. I think of m for movement. It's how you move on the graph. So anyways, it's slope times the quantity, parentheses mean multiplication, x is a variable, minus whatever the x-coordinate of your point is. Okay, so this is what point-slope form looks like. You can use this to write the equation of any line, including our profit line, or if there's a random line, it doesn't matter, you can use this. So to label these, m is your slope, x and y, or I guess I should say x1 and y1, I'm going to highlight those, are where you plug in your point. Okay, so this is the x-coordinate and the y-coordinate of your point. And then y and x will be left in as variables. So for our example, we would take y, and then we would subtract our y-coordinate. Our y-coordinate is the second coordinate here. It's -40. I'm going to put negative in parentheses because there is a double negative here. It's y minus your y-coordinate, and your y-coordinate is negative. And that's equal to your slope. Plug that in for m. And it's x minus whatever your x-coordinate is. Okay, our x-coordinate is the first coordinate here. It's x minus 8. There's no double negative there. And you always want to simplify at the end if needed. Whenever you subtract a negative, it's the same thing as adding. So y minus -40 means y plus 40 equals my slope times x minus your x-coordinate. So again, the only thing I simplified was, I'll rewrite that. This said y minus -40. There was a double negative. When you subtract a negative, it's actually adding. And this would be the equation of your line. And it's important to note you can do this with any point on the line. It doesn't matter. You could use the y-intercept, the x-intercept, or you can use any random point. It doesn't matter what you choose. I just picked one. So I could also write an equation for a line with, let's say, this point. Okay, this is what's nice about point-slope formula. You can use any point. So that's the point 2080 over here. And I'll do it again, just for good measure. So I could say, my point is 2080. I could say y minus my y-coordinate is 80 is equal to your slope, which stays the same no matter what points you pick, and x minus your x-coordinate. And this equation here is equivalent to this equation here. Okay, if you don't believe me, go ahead and actually multiply this out and move the 80 over. Do the same thing, multiply this out, move the 40 over, and you'll see they're exactly the same. So you know what? I want you guys to do that on your paper. This is good algebra practice. I want you to distribute the 10 here and then move the 40 or the 80 to the other side. I'm going to pause the video. I'm going to do this as well, and I'll come back with the answer. No cheating, no peeking. You're pausing your video right now. Okay, so I showed the work here to show you that if you isolate the y in either of these equations, they are exactly the same equation. That's why it doesn't matter which point you pick. So first I distributed the 10 in either. So for this one I got 10x minus 80. This is 10x minus 200. Okay, then I moved the number over to get the y by itself. So I subtracted 40 here and got y equals 10x minus 120. Or I added 80 here and I still got y equals 10x minus 120. So, moral of the story, it doesn't matter what point you choose, but to use point-slope form, you need a point and a slope, and then you plug those numbers into here and you have yourself an equation. So this equation, either the two highlighted or the two we originally started with, okay, right there and right there, you might want to star those on your paper, are equations to represent this graph, which means they're equations to express profit, which means they're equations you can use to calculate profit. And that's the point of writing this in point-slope form. If you have any questions, please don't hesitate to ask. Otherwise, have a good rest of your night.